All right, greetings YouTube, greetings scholars. We have this question that comes from Calculus for Business. This comes from section 1.8, question 21, and we're asked to find the second derivative. So, let me see. We have this f, okay. First thing we'd like to do is rewrite it as a rational exponent. So this is going to be the same as x squared plus 3 to the power of 3 by 4, okay. So then when we go to take the first derivative, the power comes down. We get this x squared plus 3, and then if you subtract 1, it's going to be to the power of a negative 1 by 4. Okay. So then we have to say times the derivative of the inside function is going to be what? Just 2x. And let's take it a little bit further. So notice this 2 is going to turn this 4 into a 2. And we're going to get 3 by 2x. And then this guy persists. This x squared plus 3 to the power of a negative 1 by 4. Okay. So then we have to use the product rule. When we're going to take the second derivative, so f double prime of x, we have to use the product rule. First times the derivative of the second plus the second times the derivative of the first. So the first is this 3/2 x. The derivative of the second, the negative 1 by 4 comes down. The x squared plus 3 persists. Now the exponent is a negative 5 by 4. And then we have to say times the derivative of the inside function is just going to be 2x. So that's the first times the derivative of the second plus the second, which is this, times the derivative of the first, which is just a 3/2. Okay. So now here's where the challenge starts. We have to try to sift through this and cancellations, combine like terms, things of that matter. Okay. Well, no, that didn't change anything. So this 2 can cancel this 2, right? Because they're all being multiplied and divided. Let's see. It looks like we have a 3x squared over 4 that persists. So let's see. I'm just going to do this for now. Here on bottom, it looks like we're going to have this x squared plus 3 to the power of 5 by 4. Let me write that 5 a little bit more clean. 5 by 4. Let's see. It looks like we also have a 4 that persists on the bottom. And then on top, it looks like we have a negative that persists. And it looks like it's a negative 3x squared. Okay. I think we accounted for everything. The 3, the negative 4, the 2 x's, and that. Okay. So then we're going to say plus. On the right-hand side, for the right term, we have this x squared plus 3 to the power of 1 by 4. Okay, it looks like a 2 persists on that one. And on top, it looks like we just have a 3. Did I introduce an x before? It's fine. We're just going to go with it. Okay. So then in order to combine these, we need to get a common denominator, right? So what I'm going to do is multiply this second one by 1 in the form of 2 times x squared plus 3. And I'm going to write it as the power of 4 by 4. It's really to the power of 1, but I'm writing it as 4 by 4 so we can see that we're adding those exponents. 2x squared plus 3 to the power of 4 by 4. Okay. So that should give us our desired denominator that we want. And then let's try to simplify this numerator. So then the negative 3x squared persists. Okay. So that blue part, the x squared plus 3, that's really to the power of 1. All right. Okay. I think last time I had an extra x there. Let me see. Am I missing my x somewhere? It doesn't look like it. So let's keep going. I think this is looking a lot better. We're going to be distributing a 6 into the parentheses there, right? So we're going to say plus, that's going to become a 6x squared, and then plus 18. Yeah, this is looking a lot better. On bottom, we have our desired denominator. So we still have this x squared plus 3 to the power of 5 by 4. And the 4 persists. And then 6x squared minus 3x squared is exactly what we want, right? X squared plus 3, power of 5 by 4, the 4. And on top, we have our 3x squared plus 18, okay? So no cap. I did this a moment ago and I had an extra term. I think when I did it before, I had an extra x in there somehow. So I was like, okay, I couldn't find my mistake. So I was like, okay, let me just redo everything and just take my time. And it worked out, right? I think this is the correct answer. And we can confirm it. Let me just do a quick comparison. Let me copy. And I think we have the result right here. Let's paste and you can see it side by side. Okay. Yeah, that's right. I said cap. Your ears do not deceive you. I don't know. I just did. I mean, it ain't anything, to be honest. It took me a while to understand what that meant. I was like, what does cap mean? I was like, it sounds like they're saying no lie, but it didn't make any sense, but I was like, whatever. And I don't know, it just comes out sometimes. Right? It looks good. We can factor out the 3 and we would get the same thing. And I think we got it. Okay. All right. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.